using a comment. So type 2 slashes and say integer plus integer is an integer. Double plus double is a double. For all types, please use a capital letter at the beginning. It's a good habit to get into. It will become more obvious in the next couple of classes why we do that. It's more of a convention. And then finally, your question. What happens when 19.1 and 10 are added together?
If you did 19.0 plus 10, it would give you, it would print the decimal.
It would not print the decimal. So that's the thing I was about to say, is the thing about the playgrounds on the right is that you can't always ascertain the type from the appearance on the right-hand side. So this notion here, double plus double is a double, but it has the number 20 here. It doesn't say 0.0. So you cannot trust entirely what's going on over here.
What you see,
Yeah, you can't trust what you see. You have to trust what you know over there. And so this notion of double plus double is a double, I'm going to demonstrate that farther down here when we actually start talking about division. Because it becomes, this notion of type, operation type, is another type. It's very important when we start to get to division.
So, I mean, isn't it simply because playground is used for the validation of functions and logic as opposed to...
I don't know if there's a good reason. I don't know if there's a good reason for it at all.
Yeah, I would say that's not the reason, because with the later version, so when we started taking this, we were doing it in December. And between December and now, there have been several updates that have actually made sense of things like this that didn't make sense before.
Yep.
So little by little, they keep working on those little things.
Have you seen the latest update from the other day?
The
loops. Oh, it's going to be awesome. When we get to control flow.
Really?
Oh, yeah. They draw line charts of like values in for loops now.
Oh, wow.
It's like a little one. It's
Interesting.
So yeah, so cool. I can't wait to get there.
That's a
Okay.
perfect
But
example.
I'm going slowly enough because I want to make sure that everyone who hasn't programmed before is starting to get to like talk about values and types. Like when we talk about integers and doubles and all that stuff. Like what and like how it actually affects your thing. But anyway, it's awesome. It's super awesome. Subtraction works the same way as addition. So it should be super familiar for you from mathematics. Multiplication, also the same, but we use an asterisk instead of a times symbol. Times symbol is very hard to type on a Mac, but convention is actually for most programming languages use an asterisk for multiplication.
Can I say something?
Yeah.
So if you go up a bit, where you made the 20, and if you go on the right side,
Oh, right here.
yes, if you touch that, it
Look.
shows the point.
Yes, it does. Oh yeah, that's a good thing. I was going to show that before I forgot. The playground has a bunch of neat little features that help you peer into the life of your data and peer into the life of your code. One is this little eyeball here, this little inspector icon. So go ahead and click on that on any result that you have on the right. So we talk about code on the left, results here, and then this little inspector. So that says 20.0. And if we type and if we click on it up here, you notice for 321, it does not have a 0.0. So in this case, it looks like it's a little bit more accurate. So I have a feeling that Apple will probably take care of this at some point. If there's a result that you're particularly interested in, say you're writing a bunch of code and down at the bottom there's a place where you're taking the results of all of these important calculations and coalescing them into one grand unified code, chunk of code, you can pin that value by using this. So it will write the result in line here for you. So if you start to change this line, it will also start to update that result right with you, so you can see it nearly where you're typing, like almost where you're typing the code itself.
Do a lot of other languages have this?
Nope. JavaScript has like services online, like codepen.io and whatnot, that are very similar to this, but it's much more difficult because it's like tangled with CSS and HTML. It depends on what you're trying to do, but in general. Most programming languages provide you with a command line version of themselves, so Python or Ruby, and Node now, which is JavaScript on the command line. That experience is much different from what you have here. This is interactive. It has it has all these visual introspection features on the right. It's really a kind of luxury that many of you probably don't fully appreciate because you haven't experienced the pain of the command line.
Which is fine.
Which is just fine. Like, no one will judge. But no, like this is super Swifty.
And for app development, like unlike with web apps, you need like a few different languages. Do you only need Swift?
For our purposes, we'll probably only need Swift. Did anyone have to drop into Objective-C in the last class when you took it?
I would say maybe, depending on what you want to do with your one project. So, Facebook does not have a Swift API. They have an Objective-C one. So we had to touch some Objective-C. But those would be the only two languages, Objective-C and Swift.
All right, yes.
This is just a logistics question, but do you need, because I've noticed that when you didn't put a space in, like after 19.1 space, addition sign, like it still worked.
Oh.
So are you just doing it for
That's a good point.
like visual purposes?
I'm
or is
doing
it
it-
a
Yes.
habit we should get?
It's something that I would recommend you get used to
Okay.
because it makes your code much easier to read.
Okay.
So I do it for visual purposes. I do it for like I actually like to read when I'm writing code. I like to see 10 plus 11 written out with the space here.
Mhm.
That's a good point. Swift is what we call white space agnostic, meaning that it doesn't care how many spaces that you put between stuff. And sometimes it doesn't even care about new lines either. So, like, I can put as many spaces here as I want, and it still thinks that that's a valid expression.
But don't do it.
But please don't do that. But it's
With other languages.
it's perfectly legit to do this. I'm sorry.
So that's not always true.
It's not always true. Generally, spaces, most languages are pretty forgiving. Python is the notable exception, where spaces and tabs have meaning to the language. So it is not white space agnostic. Like when you indent in Python, it means something to the interpreter. In Swift, it does not. Okay, so a couple more points about types and arithmetic. So these lines right here, if you've never coded before, please pay very close attention. Because that notion of an integer plus an integer is an integer, or a double plus a double is a double. For division, it actually makes a big difference because you can actually get different answers depending on the types that you're using. In this case, 22 divided by 7, where both are integers, gives you the number 3. And that 3 is truly a number 3. It just does not compute all of the rest of the decimal places that you get. So this happens a lot, believe it or not, where you think you're working with one data type and you're actually working with another. Especially if this has to do with, say, the locations of stuff on a screen, and you're trying to take the result of this and multiply it by 100 because you're trying to scale an image or something, and all of a sudden you realize that everything's like not quite as smooth as it should be, usually because you're doing integer division instead of floating point or double division. So in this case, in this example here, you see that 22.0 divided by 7.0 is a double on the other side. So here we get the full answer that we would normally have expected when doing division.
So that's
this
double division.
I'm sorry?
Isn't it double?
It's double division, yeah. But doubles are a form of floating point, so it wasn't incorrect, but it's better for consistency, you're right. So if I do this, a double divided by an integer is still a double. So the way that Swift deals with these arithmetic combinations is it takes the most complex numeric type and picks that as the numeric type of the whole. things start to break down when other operations start to come into play. Let me show you this one too. So the same thing here. So 22 divided by 7.0. So an integer divided by a double ends up being a double. So Swift is actually taking the numeric types and has created a rule for you that tells you that when you're combining types in an arithmetic setting, it will figure out sort of in your best interest what the answer should be. Other languages might complain if you ever try to do this, but most modern languages don't.
And does it always round down for integer division?
It's always round down for integer division. No, sorry, it's for this case, it's actually not rounding. It's a phenomenon we call truncating. So it's actually like whatever this was, it just cuts it off like a piece of paper. It's like it wasn't even there.
So if it's 3.9, it's still 3?
It's still 3. That's right. Yeah. Yes. So let's confirm that. Boom. See, 390 divided by 100 is 3.
How come
So
when you like click that, it doesn't show you what was truncated? It just still shows you
It
3.
doesn't matter.
Because it doesn't know.
So it's not like it's like stored in like
No.
some.
No.
So that's your comment about computers being dumb.
That's dumb.
Yes.
That's dumb.
Yeah.
That's dumb. Yeah. You had a question?
So floats, something can't be a float and a double at the same time. You just don't necessarily know which one it is based on what's represented.
That's correct.
But trunking doesn't actually fundamentally change what the number is, it's just how it's represented.
No, that fundamentally changes what the number is.
Oh,
So
okay.
this number 3, that's really number 3. So this is what I was saying before. If you try to redeploy this number, like you have to be very aware that you're truncating something here. Does that make sense? It's terrifying.
Just
But
add one thing. So don't think of it as it being an integer and a float at the same time. It's either an integer or a float.
Yeah.
Now you could do the same things you do to an integer, you can do to its float equivalent. But don't think of it as it's an integer and a float at the same time. So you could do everything you do to 1, the integer, you could do to 1.0, the float. But get into the habit of identifying them as 2 separate data types, because they are 2 separate data types. Yeah. And it'll become a lot clearer when you guys start playing with, I think there's a homework that's coming up where you have to work with a tip calculator. It'll become more evident there where it's really 2 different data types, and it's important to have that distinction.
does it make any sense? So
The
somewhat.
float is
Yes.
the float is the one that keeps going.
Yes. It's the one that has the ability to have as many decimal places as you practically
So that
want.
takes more space.
Yeah, it takes a larger chunk of memory, but we're not actually worried about memory in terms of the apps that we're writing, so you shouldn't have to worry about it. In any case, the integers, yeah, 64-bit integers and doubles should be the same size, I think. Isn't that right? These are all 64-bit integers we're dealing with. We don't actually distinguish between them.
Well,
They're all
I mean,
32.
I don't know if it changed, but when we came to this, they were actually 32 bits.
They're 32 bits.
Yeah, and we were running into errors when calculating large numbers, and we had to convert them into 64.
Okay, so that's why. Okay, interesting.
So
Okay.
he has
That's
asked,
not. I'm sorry.
he's asking what that is, the 32 and 64.
Yeah, let's not worry too much about it. We can come back to that later.
Does a float take less disk memory than an integer then?
No, we'll come back to that later. Okay, look. There's 32-bit stuff that takes, it's 32 ones and zeros. And there's 64-bit, which is 64 ones and zeros. There are 32-bit integers, 64-bit integers, 32-bit floats, and 64-bit floats, which is also known as a double, because it's twice the size of
Right.
a float.
Okay.
So what we're talking about now is this precarious problem where you don't quite know when you write 1 or 1.0 what Swift is giving you at any given moment, because they keep changing stuff on us. They being the Apple folks. So, and then Angel was just relating the story where they thought that integers were 64-bit, but they're actually 32-bit. So nevertheless, it's a problem that you might encounter, but the distinction that we're actually most important trying to make isn't necessarily the bit width, 32 or 64. It's just the fact that there are these integer types that are positive, negative whole numbers, and floating point types, which carry decimal places. They're probably more representative of what you want in some cases, versus the counting nature of integers, which give you the ability to count by whole numbers. Does that make sense? Okay. Sorry that got kind of conflated, but these types you're going to encounter, so in some contexts it's good to know what the difference in meaning is. All right. So the last bit of stuff here is well, let me move this up. There's another operator that you're probably not accustomed to, that you might have dealt with in mathematics, but you might not have. It's called modulo operator, modulus operation. This is an operator that takes two integers and gives you the remainder after you divide those integers together. So if you take the number 10 and divide it by 3, you get what? Remember this? You get 3. What's the remainder? 1. So the modulo operator, this percent sign, will give you 1, the remainder. So in some cases, when you're dealing with division, you can get all the information that you need after a division operation by using the modulo operator. So we get 3 here, but the remainder is 90 after typical division. So you remember calculating the remainder when you're in elementary school, and you never had to calculate a remainder ever again in college life? That's sort of a weird thing, isn't it? It can often become very important in programming. So if you want to count 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3 over and over and over again, you can use this operator to get those numbers in a very patterned way. So you might end up using this. Down here, order of operations. What are the order of operations for a typical arithmetic? Do you remember? I'm sorry?
Pandas.
Oh, is that a mnemonic? Yeah.
Say it proud.
Yeah, say it out loud. No?
Say
The mnemonic, the mnemonic, and then what it stands for.
Please excuse my dear Aunt Sally.
Okay, and then what does it stand for?
Parentheses, exponents, multiplication, division, addition, subtraction.
Awesome. Do all of you have a mnemonic like that you remember? I never had a mnemonic.
What did she say after Moss?
Please excuse my dear Aunt Sally.
Please excuse my
That's
dear
easy.
I
It's the one I had.
I never learned it.
Maybe we're weird.
All right. So minus the exponent, the order of operations is exactly the same. So here, the order of operations 1 plus 2 times 3. It's going to execute 2 times 3 first. So it actually mimics arithmetic operations. So arithmetic order of operations. So 2 times 3 is computed first, and then the addition is computed afterwards.
So it's not so dumb.
It's dumb because if this isn't actually what you wanted to compute, it doesn't care. Here, you can override that order, of course, by using parentheses. So in this case, just as you might type it out in a paper or something, open paren, as we say, 1 plus 2, close paren, asterisk 3 or times 3, now gives me 9 instead of 7. So the challenge for you before you move on to the next one is I've written out the calculation here to convert Fahrenheit to Celsius. So you'll see 212 degrees Fahrenheit through that formula gives me 100. Your challenge is to go the other way. Take some value in Celsius, 100 degrees Celsius, and convert it to Fahrenheit. Type it out in your playground.
How do you do exponents?
Exponents, you have to use a function. Isn't that right? shouldn't need it to convert Celsius to Fahrenheit, though.
No, I was just curious.
I'm just kidding.
Okay.
All right. So we'll give you 2 minutes on that one, and then. You all know what the correct answer is, right? Yes? What? Any metric system fans in here?
Yeah.
That's it.
Thank God. But we're getting there here too.
Yeah, slowly.
We are not getting there.
Very, very
Oh,
slowly.
yeah.
We are not.
Oh, yeah. A few generations. We
The
get
scientific community is
it.
there.
It is, so we're getting there.
Yeah.
We all remember the 60s.
We're all scientists at heart.
I only came 10 years ago.
So did you give me a way to stop that? Okay. Is everybody done? Everybody has something? It's working? Okay. All right. Sean, start us off. Give me the first piece of your conversion.
I think I did it the wrong way.
You did it
Are we,
wrong.
are we supposed to use what you have up there?
Oh, I mean, did I give you a hint as to what the answer was? Do you know what the conversion is? You could have Googled it too.
I did. That's what I did.
You did?
Yeah.
Okay. And then what? Did it give you something that wasn't computing properly?
Well, I'm getting
All right.
100 times 9/5.
9/5.
But
Then did you do this?
so parens on both on the around the 9/5 and parens around the left parens on the far left and then another right parens.
Over here,
Yeah.
like that. And
No.
you do the red dot.
What's that? One more. 2 right parens right there. And then plus 32.
Okay.
Those parens are not necessary. You just
And here.
operate a function based.
That's.
Yes,
I think that's right. Who else has a different answer? Do you have a different answer? You know how to do this stuff.
No, I don't have different.
I'm sorry.
No, I don't have different answers.
You don't have a different answer with or without the. You had parentheses as well.
No,
No. Okay. So what did you write?
I didn't have any parens.
Okay. What did you write? Spit it out.
I got.
Remember, it's about syntax, so the differences in syntax are useful for
Oh
everyone.
yeah, I did 9.0, 9.0, 5.0.
And 5 points. So what did you actually type? What was your whole expression? I want to show people that I want to show the rest of the students that haven't coded before the fact that you can be given one problem and come up with slightly different answers syntactically. So
So I actually did just 100 multiplied by 9.0 divided by 5.0 plus 32.
plus 32. Oh, same answer. Excellent. Allison, do you have an answer?
I have 100 times 9 divided by 5 plus 32.
Excellent. That's interesting, isn't it? All right. What I would like to, I know what you're about to say.
Okay.
So what I'd like to do is let's convert a different number from Celsius to Fahrenheit. So if I change this to 10, I get 50. If I change this to 10, I get, it's not going to work.
It's not gonna work with those examples.
I'm sorry?
It's not gonna work with those examples.
Not going to work, yeah, because I'm choosing ones that are just like spot on correct, right? There we go. All right, so
That's good.
can someone tell me what happened here?
Got truncated, we could.
Yeah, okay, go ahead. I want to ask, trying to remember your name.
Ned.
Ned. Damn it. Okay, Ned, what happened here?
So
Sorry?
it's got truncated.
It got truncated. Why did it what does that mean? Why did it get truncated?
Because we didn't have enough enough digits in the inputs, so they didn't go those.
Enough digits. What does that mean? Constantine, what do you
We
think?
did not tell him
We didn't.
that it's integers only. I mean,
Right. We did.
we did,
Right. We
we did
told.
not put a zero somewhere.
That's right. How would you have described that
We
issue?
didn't use floats.
I'm sorry?
We didn't use floats.
That's right. We didn't use floats. So why was that an issue in this expression?
Because it's
Yeah.
truncating
Like-
the end result.
I know. Yes. Which operation was responsible for that dastardly deed? The times, the slash, and the plus. Which one did the truncating
The
for us?
9 divided by the 5.
That's right. So this guy right here. It actually wasn't 9 divided by 5. What actually was the answer? What actually was the operation performed right there? I know you know it. I want to see our students.
Because 108 is divisible by 5.
I'm sorry? That's one.
108 is divisible.
That's
So is the
right.
lesson
So-
here you just always add a decimal point? Is that where we're going with this?
When you're doing math, like just straight up math like this, yes, it's probably in your best interest to add a point zero somewhere to convert the entire expression to an operation on doubles. Sometimes that falls apart depending on what you're doing. Like modulus sometimes doesn't work very well. A couple of notes before we take a little break. Division by zero is just as egregious in computer code as it is in mathematics, so that can sometimes cause troubles. And I think I crashed my playground.
No, you shouldn't have. They kind of fixed that.
I was having all sorts of trouble writing these playgrounds on Saturday. It was terrible.
Well, this used to crash your Xcode.
I'm sorry?
This used to crash your Xcode.
Really?
So you're trying, you keep trying.
That's
I'm
ignoring you.
trying, and it's just ignoring me.
Yeah, it's ignoring you rather than crashing your computer.
Yeah, there we go. So
That's how you tricked it.
I tricked it by using doubles instead.
Is it saying infinity?
It's saying infinity. Believe it or not, doubles have a value attached to them, infinity and negative infinity as well, right? So you can actually start to talk about scenarios like this. So in some cases you'll use that value explicitly, like the infinity value. Sometimes you won't. Most of the time you won't, actually, but you should know that it's there. So whenever you see inf, that means infinity, which means somewhere in your computation you've divided by zero.
So,
Present doesn't say undefined. Or do I
Sorry.
remember that from 11th grade?
It's undefined in terms of the true mathematical definition. in here, it's actually treating it as if you were following that asymptote to infinity. Yeah. It's telling you that whatever that value is, it's much bigger than anything else you could possibly express using doubles.